Well, good afternoon, everybody, and welcome to this final session in our short series on the influence of AC power lines on buried pipelines. We're going to be focusing today on the Eskom Guideline, which governs or regulates the interaction between power lines and pipelines in South Africa. Today, we are very honored to have with us Arthur Berger, who is an electrical engineer with Eskom. He holds a master's degree in engineering from Stellenbosch University, has been in the Eskom high voltage department for nearly 30 years, and is currently the chief electrical engineer in transmission and involved primarily in high voltage power line design and fault levels and thermal loading and all that sort of good stuff. Arthur has been one of the drivers in this development of the guideline, which we're going to be talking about today. And this guideline has come about primarily because of a situation that arose about 10, 15 years ago, almost, not quite 15, where a new pipeline was installed, a fuel pipeline, and we landed up with a confrontation almost between two infrastructure owners because the new pipeline went onto a servitude that belonged to another infrastructure owner, except that the infrastructure wasn't there yet. And so the need was identified for some sort of rules of engagement, shall we call them, between pipeline owners and power line owners. And that's how the guideline was born. But anyway, that's what Arthur is here to talk to us about. Arthur, welcome, and over to you.
Thank you, Neil. Thanks for the opportunity. I really appreciate the time to talk to you about this guideline. It was around about 2010, and that's when I really started meeting people like Neil and Vanessa, and many of you around in the meeting today will also recognize my name. So basically, Eskom realized that it would happen again and again, that we would have the infrastructure competing for the same space, and that it was important for us to start working on a prescribed method or a means to make sure we don't get stuck every time we have to deal with one another. So this guideline was developed around about 2015. It is also the Corrosion Institute. We will see shortly that it will be updated soon. So yes, the background is that it started in 2010 roughly. The guideline was the first South African standard for pipeline construction interacting with Eskom transmission and distribution lines. The idea was to eventually create a SANS document, and Eskom basically started with our view of it when we started working on this guideline. And it was anticipated that the pipeline industry would also combine their own document as well. And the idea was to put these two documents together into a combined NRS document. However, Eskom had a bit of an advantage because we are only one entity dealing with our own issues, and we had research funding to assist us. So we were able to put our guideline together, but it's a far more difficult feat for a multi-party pipeline industry to come together and do the same. So in 2015, we published that first Eskom version of it. But as time went along, we started realizing that it might not happen very soon, that the pipeline industry would come together to produce their own version, their own view of the requirements for pipelines and power lines. So at this stage, what we are doing is we are calling on many of you guys, many of the players in the pipeline industry, to give us some comments, and we are working collaboratively with a large group, and we are opening it up and basically calling for suggestions. So 31 comments or proposals are under consideration at the moment. Also, the latest IEC and other research across the world, many of it was suggested and brought in by the suggestions we received. So at this stage, what has happened is that we see this as a a two-way street. We've decided that if we don't see the industry coming along with a guideline, we'll just open up this guideline and bring comments in and make it open to all. Because in the end, we will also need your cooperation and you will need ours. So we consider it a win-win situation when we open a document up and make it accessible to everyone and to allow people to give their comments.
So Arthur, it's fair to say then that a lot of the comments that are being considered at the moment are actually coming from the pipeline industry, saying, well, from our point of view, there are issues that you haven't addressed. What are we going to do about it?
Yes, we also want to obviously avoid extremely conservative designs on both sides of the spectrum. We don't want to be too strict on some of the issues that we can debate and perhaps adapt to be more practical. The first guideline, 2015 one, had a few conservative definitions in it because it was the first one. And now with some years of practical experience in using the guideline, we are obviously open to improve where we can obviously see the need for it. So I think when I said it was a two-way street, what we have been doing as Eskom is what we've got in our guideline, basically preaching to you, we're also practicing for ourselves. So in this case, you see on the screen now, it's a new transmission line that is currently under construction. And what we did is that we followed the same guideline with all the recommendations and limits, and we applied it to ourselves. So this is a case, pipes are already in the ground, and the power line is coming afterwards. So this is the front of the report, and you can see some of the recommendations or mitigation requirements in the report. So in this case, because Eskom is bringing the line after the pipelines, Eskom is responsible for all the costs and all the interactions that need to follow. So you can see we've got various pipe owners involved. The equipment that's already installed is involved. We also will be using insulators on the power line as well from our side to bring the full mitigation into effect. I think one of the more contentious topics here has always been the safety guidelines and how strict they should be. Now, obviously, we're looking after the steady state safety and the transient safety limits, as it is in the guideline at the moment, the 2015 version. And amongst the 31 topics being discussed now, obviously the safety limits are also being discussed and the relevance of some of it, also including the probabilistic approach, possibility of using that instead of a conservative assumption. The guideline also describes the corrosion aspect and how to make sure that both the power line infrastructure and the pipeline infrastructure are still protected in terms of corrosion.
Arthur, just to pick up on that comment about the probabilistic approach, I understand that particularly the Australian and New Zealand standards are very much more focused, if I can put it that way, on the probabilistic aspect, particularly of transients. One has to say, well, how often are you going to have a person in the wrong place at the wrong time? I know I've had a couple of my colleagues who've been affected by transients, experiencing transients whilst working on a pipeline, actually from electrical storms and from electrical interference from power lines. What is the liability of Eskom, if I can put it that way, if one does go with the probabilistic approach?
Firstly, we are interested in the probabilistic approach as well, not only for pipelines, but also for other infrastructure in the servitude, for example, play areas for schools or residential complexes and all of that. So we are doing due diligence on transit. And the reason we take seriously, obviously, is that if you look at the Electricity Act from 2006, any utility transmitting power with a license from the government, if you look at the clause 26 down there, it's quite a strong statement that says if there's any damage or injury inside a power line servitude, the licensee, which mostly Eskom in South Africa, you would be basically deemed to have been the cause for the negligence it's basically an automatic guilty situation for Eskom until it's been proven that it wasn't the Eskom power line that caused the injury or damage, let alone loss of life. So we cannot ignore it. But at the same time, we also have to be realistic about probabilistic calculations, and we look at the fault current levels and the area of the network. We look at the particular performance or faulting of a particular line. We look at the fault clearance times and all of that. So there is a healthy debate on the go, specifically now with the update of this guideline as well. So this guidelines debate will also be followed for anything else that we consider like a school play area or such.
This indicates some of the more obvious situations that can occur, particularly when you think of some of the open areas around power lines where people are active. And one of the aspects that did occur to me was that we've been using modeling, as we saw in the last couple of discussions, both for the steady state and the transient side of things. But the question is that modeling overly conservative? We are seeing that the cost of AC mitigation in a project nowadays often far outweighs the cost of cathodic protection, for example, from a corrosion point of view. And the question is being asked, is it really necessary? But of course, when life is at stake, the answer has to be yes.
I suppose so, Neil. For example, when we have the luxury of choosing the new route for a power line, one of the things we just try to avoid, obviously, is close proximity of a power line structure to the pipe itself. We first choose our bend points where the line has angles, the route. So the worst situation for us is a bend point that is close to a pipe, because it's difficult to move a bend point once the line design gets going. Suspension structures, we can move them forward or backwards along the alignment. Those are not too difficult to take care of. But so the first thing that we do is we try to avoid a tower very close to a pipe, because that is where the mitigation becomes quite expensive. But yes, we obviously have to be very careful. Now, you can easily say yes, but Eskom has so many people squatting or living illegally in their servitudes. That is a huge concern, of course, for people who understand what we're looking at here. But it's a social issue sometimes that is bigger than Eskom. Not easy to move people away from these lines. But at the same time, we also don't want to make it worse by putting a dangerous situation on something like a pipeline, which just multiplies the risk in some of these situations.
Yes, of course. I think what people don't realize is actually the magnitude of the risk. If you have a look at this data that you've given us, you look at the left-hand side of that, that's the current that is being dealt with by the transmission system under fault condition. And well, I mean, it's like lightning strikes, presumably. We're talking about thousands of amps. Everything's measured in kiloamps, not in amps.
Yeah. And the energy here, I mean, if you compare lightning strike to the fault clearing time of a transmission line, we clear most of our faults within 100 or 200 milliseconds, where lightning strike is over and gone within a few microseconds. So the energy, if you compare the time from a few microseconds to 100 milliseconds, it's just a lot more. But we do have the overhead ground wires conducting 80 to 90% of that back to the source, but the 10 to 20% that goes down the tower into the ground, that conductive coupling is really, really the issue. So this is still low, Neil. If you look on the left-hand side, 16 kiloamps, that represents more or less a station far away from a power station, but close to the power stations, we are looking at 50 kiloamps. So we have to really check for the towers close to the crossing or in a parallel section what the fault levels are, and deal with it in that way to make sure we take care of the risk.
And Arthur, so therefore, to make sure that this evaluation is done properly, we need a lot of detailed information about the power lines in order to calculate what the effect of that is going to be on a pipeline. And I'm not casting any aspersions here, but we do hear of people saying, how on earth do we get hold of this information? Because we don't even know if the tower belongs to Eskom or to the local municipality, or to Transnet. And within Eskom, is it Eskom transmission? Is it Eskom distribution? Is it Eskom regions? Is it Eskom head office? Where on earth do we go? So maybe you can help us to point our questions to the right people.
Look, we do have a flow chart in the guideline. This is Annex D. It's 4 pages long. But if you just look at the first page on the left, there where the start function is, it says submit the pipeline application plus design details to Eskom land and rights. Now, in the case of transmission lines, we have a central office in Megawatt Park in Sandton. And there's a single person whose name we will share with you. She deals with all servitude applications for transmission for the whole country. So in terms of transmission, it is relatively easy as long as this person gets the request. As soon as she can see that it's a pipeline request, she will funnel it to us, to the transmission line design team or the technical team. So Ms. Lungile Motsisi has been in this position as well for the best part of 10 years already, quite well known to many people. There are regional offices, like if you go to Witbank, you'll pick up a contact there with someone, but they will always refer you to Lungile if it's a transmission line. If it's a distribution line, unfortunately, they have regional offices, which are making it a little bit more difficult. But this is off the Eskom distribution web space just last week. So if you look at the areas here, you would see Monde Bala at the top. Now, I wouldn't call Monde, and it would obviously get him quite upset if he gets a call for a pipeline application. But each of the areas in distribution have their own office and their own manager. You can see there's cluster names right at the bottom: Cape Coastal Cluster, Gema Cluster, Gauteng. So really, I would say the people at the bottom row of this list, they are the people you can make contact with and ask for the land development representative for that cluster, and then send it to that contact person. So eventually, what we're trying to avoid is that you apply and it gets to transmission and we say, yes, it's all fine. And there's also a distribution line sitting next to transmission, and then they stand up and say, you never spoke to us. I think a contact is all we need, and between Lungile and whoever responds from that area, it will be combined. Because what we do is, and we will see it also in the guideline, is we collect information of the whole pipeline route, and we get information of all the transmission and distribution lines. So it's a GIS, or basically a mapping exercise. So we will identify all parties and make sure that it's all, technically it has to be all together. Otherwise the study will not be valid.
Thanks, Arthur. I think that's great. The challenge from the pipeline owners always is, well, who does this tower belong to? There's nothing on the tower that says, I'm a distribution tower, or I'm a transmission tower, or actually, I belong to Transnet, or I belong to Centurion Municipality, or whatever, because there are municipal power systems around. I think the other thing we need to remind people, because I've had a couple of queries recently, is at what level is it actually a problem? There are so many medium voltage lines, the 11, 22, and 33 kV lines that crisscross country. We're not really concerned about those because they neither have the voltage nor the current levels that give us problems, except perhaps if we have an above ground pipeline in close proximity. Yeah. Would that be fair to say?
Yes, Neil, definitely. I think the best thing to do always is to get your infrastructure on a Google map or Google Mapping, and to indicate the towers or the lines that you are not sure about, because we can overlay that with the Eskom GIS systems and figure out quite quickly whether they belong to Eskom and who they belong to in Eskom. Mm-hmm. So I often do that. I had another request this week from a customer in the Eastern Cape. So it's quick. If we get a coordinate and a photo, very, very quick to determine who it belongs to. We do that a lot. We try to make sure that the wheels keep rolling. because we know how frustrating it can be. Even for me, finding some of these, people in distribution to talk to, not always easy. So I know what you're going through. And just one thing I want to add, if you look at the list of people at the bottom row, they have their own grid planners or their, planning staff. And they also need to supply future lines that they've planned that might not be on the ground yet, because it's no use. We take care of everything we see, and then they build a new 132 kV line next to your pipe just after you've completed your installation. So that the same transmission, the case files that we get from our planners include everything up to 2030 or 2040. So that's the way we take care of the future developments as well.
Thanks, Arthur. No, I think, Arthur, one of the things that people may not realize is that every single tower has a unique identifier. And all you need is sometimes you don't even need a pair of binoculars to read that identifier. And if you can report that identifier to Eskom, doesn't matter what department it is, they will be able to identify that line a lot more easily. In concluding then, I think we need to just wrap this up. Perhaps you can take us through this last slide.
Yes, thanks, Neil. I think we have to make peace with it. We're gonna be in the same servitudes, and it's always better to cooperate with one another than to try and just push your own agenda. So I think we've demonstrated that we are really open, and we really don't want to cause any difficulties, but we have to take accountability for risks and for people's safety. And I also still believe that a power line and a pipeline can always coexist if we coordinate it properly. The cost of the mitigation might be high, especially compared to the cost of a pipeline, but it should never be prohibitive in a way that we cannot make the two systems, work together. The steady state AC safety mostly achieved with the use of zinc ribbons and controlling the AC voltage on the metallic parts that people can touch. We are also quite concerned about transfer potentials, Neil. If there's a fence or something that is in contact with something that is close to a tower, that potential can be transferred far away, and people might not expect when they touch that fence. The transient safety, obviously all the control earth mats and grounding systems that are described in the guideline have worked well for us, and I think we always look at systems that don't need a lot of maintenance and that are not prone to theft, which is not an easy task on many occasions. The DC corrosion protection, the pipe, what that it induces basically is it could induce that current onto our line. So we are just taking care of preventing that current from entering our line and moving along the line to corrode our tower legs. So the key, I guess, is just to start timeously with the process. It's also very unkind to drop in on someone at the last minute and say, I've had to do this now, and it's a big job, and now we're all your enemy, and what. We are obviously trying to just get a heads up as soon as we can. And we also do the same with our projects. Before they even go on construction, we hand them the full study report. We make them aware of the costs and the time impacts that they will have to deal with when they build the power line, and they have to make sure the pipelines are mitigated for safety. So it's just a frame of mind. We have to know that this takes time, and we have to cater for that. That's basically the main message. Thank you.
Thank you, Arthur. I think that has been a very useful discussion. We appreciate your coming forward to put Eskom's side, if I can call it that, on the table. To remind you that in October, we're going to be opening a can of worms. And because the title of our October lunchtime discussions is very, very tasty. It's called Looking at the Hidden Dangers of Cathodic Protection. With that, thank you. Enjoy your afternoon.